Jellyfish have drifted through the world's oceans for over 500 million years. They were navigating the seas long before the first dinosaurs appeared on Earth. They lack nearly every feature we associate with complex life. They have no brain, they have no bones, and no heart. Their bodies are 95% water. Without the support of the ocean, their entire physical structure collapses into a featureless mass. Take them out of the water, and they become nothing more than a gelatinous blob. It seems impossible for an organism this fragile to survive in environments filled with complex, high-speed apex predators. But the jellyfish is not a primitive failure. It is a biological minimalist, where every missing organ has been replaced by a highly efficient workaround. Lacking a skeleton and complex musculature, the jellyfish relies on its flexible, bell-shaped body to manipulate the water itself. Small species use standard jet propulsion, contracting their bells to squirt water backward. As jellyfish grow larger, this water volume becomes too heavy. Instead, they use rowing propulsion. The bell's flexible margin flares out, creating a vacuum that pulls the animal forward. Because this relies on pressure manipulation rather than raw muscle power, jellyfish swimming is the most energy-efficient movement ever recorded in an animal. This efficiency extends to their neurology. They don't need a brain to hunt. They use a decentralized radial nerve net to automatically process the world around them. Their tentacles are embedded with nematocysts, microscopic, venom-filled harpoons that fire automatically in milliseconds upon physical contact. Deep-sea species push this further by using bioluminescence. They generate their own light to draw prey directly into their waiting tentacles. By combining these automated systems with hyper-efficient movement, the jellyfish effectively turns the surrounding water into a self-sustaining trap. Their reproductive strategy is designed to maximize numbers with minimal effort. They begin life as free-swimming larvae before transitioning into a stationary state. Once the larva settles on the ocean floor, it transforms into a tube-like structure called a polyp. This single polyp then clones itself through a process called budding, releasing multiple miniature jellyfish into the water column simultaneously. While most species eventually die, Turritopsis dohrnii can push this entire cycle backward. When it faces environmental stress or old age, it simply reverts. Through a process called transdifferentiation, the adult jellyfish alters its own cellular state, transforming its body back into a juvenile polyp colony. This cellular reset allows the organism to restart its life cycle indefinitely, effectively bypassing natural death. By literally resetting its biological clock, Turritopsis dohrnii circumvents the standard constraints of age and physical decline. Because jellyfish require so little energy to survive and reproduce, they reach massive densities that make them a staple caloric source for giants like sea turtles and ocean sunfish. Their presence also creates a secondary habitat. Small fish with a natural immunity to venom use the jellyfish as floating shelters, hiding safely within their tentacles. But this balance is shifting. Human activity is rapidly warming global ocean temperatures. Warmer water accelerates jellyfish reproduction, while the overfishing of apex predators removes the only natural checks on their population growth. The result is a jellyfish bloom, a massive, dense population explosion that can overwhelm entire coastal ecosystems. These blooms consume plankton at such high rates that they can starve out other marine life, destabilizing the base of the ocean's food web. Maintaining the predator-prey equilibrium that keeps these populations in check depends directly on our ability to mitigate climate change and plastic pollution. The jellyfish proves that a brain, bones, and a heart are entirely optional. Its minimalist design has outlasted the dinosaurs, and in a changing ocean, it is becoming a force that can reshape entire ecosystems.